As you see here, we're going to be doing integration of odd powers of sine and cosine. Both strategies are going to be the same whether we use sine or cosine. We're going to be using the Pythagorean identity sine squared plus cosine squared equals 1 to rewrite these in a different form. And the reason we do that is because this main function is really a cubed function, and so when we check with our, to take the derivative to check our answer, we're going to end up using the chain rule, which means there's going to be either a sine or a cosine, like the opposite one, involved. So we will start with this first example here, and what we're going to do is we're going to integrate, and these two are both odd, and that's what we're going to be working with, is odd. And even if there's two different ones, like a sine to an odd and cosine to an even, you always split up the odd one. So we're going to split up sine cubed really, into sine squared times sine. And the reason we're doing that is because we can now change sine squared using Pythagorean identity to 1 minus cosine squared. And that's multiplied by sine x. And now we'll distribute this sine x, and so we have integral of sine x minus cosine squared x sine x. And now that we have it as a difference, we can just integrate these two different terms. So the integral of sine x is negative cosine x. The integral of this next one here is the main function is a squared function, so we will integrate that and we'll think, okay, well, this is probably negative 2 cosine x. I'm sorry, I did that wrong. I took the derivative. It's 1/3 cosine cubed plus c. But what I need to do is, especially this middle one, I need to check. We know our integral of sine, but let's check this one. So to check it, we'll take the derivative of it, and the derivative of this is the 3 comes out front, so we get a negative cosine squared x times the derivative of what's inside. Derivative of cosine is negative sine, which is pretty much what we want here, but we're actually off by a little bit. We're off by negative. So we'll go back and change this to a positive 1/3 cosine cubed x, and there's our answer for the integral of sine cubed. All right, let's move on to this next one. It is going to be very much like the first one, except now we're going to split this up into cosine squared x times cosine x. Again, we'll use our Pythagorean identity. So instead of cosine squared, we can put 1 minus sine squared. We will then distribute this cosine x, and so we have cosine x minus sine squared x cosine x. So if you're looking across here, these steps are all exactly the same, except we're changing cosine rather than sine. And now we're going to integrate, so the integral of cosine is just sine, positive sine x. And minus, this is a squared function, so we'll say this is 1/3 sine x plus c. We'll go ahead and check this middle term. So the derivative, I made a mistake again, I forgot the cubed here. So sine cubed. And so we have negative, so I'm checking here, negative sine squared x times the derivative of what's inside the derivative of sine is cosine. And that is exactly what we wanted. The sign is correct, it's a negative, and so there's our answer for that one. Let me just make a note here. If we had a cosine to the fifth, we would break this up into a cosine to the fourth x times cosine x. And then we could think, well, this is a cosine squared, because we always want to get it to a squared here. And then with this, now we could say, well, this is 1 minus sine squared, and we would multiply this out. So it would be 1 minus 2 sine squared x plus sine to the fourth x. And that's how that works if you get higher than 3. I think we might see one like that later. All right, so now we have both functions involved here. Sine is to an even power, cosine is to an odd, and we always want to change the odd one using the identity. So we will do that here. So we'll say, well, this is sine to the fourth x, and this is 1. This is cosine squared x times cosine x, which we can change the cosine squared into 1 minus sine squared times the extra cosine x. And now we'll actually distribute both of these because they're both multiplied by that binomial. And so we get cosine x, well, let's just write this way, sine squared x cosine x, and then minus sine to the fourth cosine x dx. And now we can integrate this. And this one, the main function is a squared function, so we'll say, well, this is 1/3 sine cubed. And over here, negative 1/5 sine to the fifth plus c. Let's check this to make sure our signs are right, and you may end up seeing a pattern with sine and cosine. So derivative of this is sine squared, so I'm checking here in red, times the derivative of what's inside. The derivative of what's inside is cosine. Derivative of sine is cosine. And then over here, we got minus, the 5 would come out front, so we just have sine to the fourth x, times the derivative of sine is cosine, and that is what we wanted. And so our answer is this right here. We didn't need to change any of the signs. Moving on to the next one. Now we have two odds. So we really could change either odd, but it is going to be easier to change the one with the smaller exponent. So we'll go ahead and do that. So we'll make this a sine squared. And some of these steps you'll end up being able to skip because you'll realize what's coming. Split this up. And then we'll use our Pythagorean identity. So this is 1 minus cosine squared times sine x cosine to the seventh. We will distribute the sine x cosine to the seventh. So we've got a sine x cosine to the seventh, and then distributing we have a sine x cosine to the ninth. Forgot the x, cosine to the ninth x, because we're distributing this into here, so we had a cosine squared and a cosine to the seventh, which gives us cosine to the ninth dx. And now we'll integrate. The main function here is a cosine, so this is going to be 1/8 cosine to the 8th x minus 1/10 cosine to the 10th x. And now I'm just kind of guessing here, but before when we had to integrate cosine, I think like we had to integrate our, there was a cosine here. I think we ended up having to change the sign. So I'm going to make this a minus and a plus. I'm still going to go ahead and check this to make sure. So derivative of cosine to the 8th, the 8 would come out front, so this is cosine of the 7th x. And then the derivative of cosine is negative sine, and so there's that negative I was talking about. And it looks like the same thing will work out over here. We have cosine to the 9th x times the derivative of cosine, which is negative sine. And we did get what we wanted, exact same thing. So here's our answer here. So it looks like when we have to integrate, when our exponent is an exponent of cosine, when we do our integration, we do want to change the signs. Our last one here, this is kind of what I mentioned on this first example when we have something, if we would have a 5 here. So that's what we'll be doing here. It's an odd one. I know sine squared is smaller, but we have to change the odd one. And so we'll have sine squared. And we'll split this up into a cosine to the 4th x times cosine x. And we'll think, well, this because we want a squared, because we want to use our Pythagorean identity. So this is a cosine squared squared. So our rules of exponents. And we are using Pythagorean identity, which is 1 minus sine squared. And that whole thing is squared times cosine x, so we actually need to multiply this out. So if you remember our rule or our helpful thing for this, we have a, I'm going to go ahead and put both of these together up front. So we got a sine squared x cosine x. Multiplying this out, we get a 1 minus 2 sine squared plus sine to the 4th. And now that you have this, it's more of the same. It's not like our integrating is going to be any more difficult. We'll just have an extra constant in there for one of them. We're now going to distribute this to all three of those terms. And so it gets a little long here. Sine squared x cosine x minus, now we're going to multiply it times this term. So we have a 2 sine cubed x cosine x. And by the last one, we have sine to the 6th dx. And I put in an extra parenthesis that I don't need here. All right, so now we can do our integration, and this should be pretty simple here now that we've done several of these. Our exponent here is with the sign, so we won't have to change our signs. And so this is going to be a 1/3 sine cubed. It's going to be a 2, but it's so it'll be 2/4 actually, because we'll have this 1/4, but so we have 2/4, which is 1/2. Sine to the 4th x, and this last one will have 1/7 sine to the 7th x plus c. And that will be our answer. You can check it if you want by taking the derivative of each of those parts. And there you have it. And that is integrating with odd powers of sine and cosine. So you split up the odd one, the smallest odd one, if if there's two odd ones like we did in the third example or third slide, and then use Pythagorean identity, distribute, and integrate each of those parts separately.